So let's finish this one off with a practice question. We'll try and cover quite a bit in this question. So the pulley system below has got a 15 Newton resistive force acting on it. It's also got, we've been told it's released from, Y is 2.5 meters from the ground when it's released. They're giving you quite a lot of information in this question. So we want to find equations of motion. So that's what we've been doing in the examples. We want to find the acceleration. That's going to involve solving these equations. We want to find the tension, which we're also going to get from solving part A. Now, find the time taken between the system being released and Y hitting the ground. This is actually a SUVAC question. Okay, we found the acceleration from here, and we're going to use that to solve this part of the question. Part E is more of a conceptual one. It's just what we've been talking about when the string has been cut. What's the acceleration of Y going to be? This is not an easy question at all. It really is a proper exam standard question. Okay, so don't worry if you struggle with it, but it's well worth having a go. Try and write some equations of motion. Think about your sign convention. Think about which way this system is moving. I'll give you a clue. Y is moving downwards, isn't it? Okay. Parts B and C, you're going to need to solve simultaneous equations to do that. Have a go at this question now. If you've got a moment, it doesn't matter if you don't get too far with it. It's just worth having a think about it, and we'll go over the answers in a few seconds. Okay, hopefully you've had a chance to have a bit of a think about that question and maybe get some answers written down. So let's have a look at it. So we want to do some equations of motion first of all. Let's have a look at Y to start with. We need to think about the forces first. There's weight acting downwards. That's equal to mg, and the mass of it is 8. So the weight is going to be 8g. And there's tension here, upwards on the cable. So the resultant force, and remember this system is moving like this. Y is moving downwards, so I'm going to take that 8g as positive. So my resultant force is 8g minus t. Okay? That's my resultant force. Now I can set that equal to ma, can't I, using Newton's second law, because the resultant force is equal to the mass times the acceleration. Apologies, the mass is 8 kilos. So there is my equation of motion for particle Y. For particle X, we've got tension acting this way, and we've got a resistance force of 15 newtons acting the other way. This particle is moving that way, isn't it? It's moving towards the pulley, so the T, the tension, is positive. And I get T minus 15 for my resultant force, and that's going to be equal to ma. Think about Newton's second law. Remember, we're always using this, that the resultant force equals the mass times the acceleration. So T minus 15 is going to be equal to the mass, which is 5 kilos, times the acceleration. That's part A done. We've got the resultant force for both X and Y here. For part B, we want to find the acceleration of the system. We've got to solve these simultaneous equations now. What I'm going to do that is add the two equations together. This is normally quite useful because the tensions will normally cancel out. And you can see they're going to here because I've got a minus t in this equation and a t in the bottom equation. So if I add the two equations together, I get 8g minus 15 equals 13a. Okay, I'm not going to go over anything more about these simultaneous equations other than that's how you do it. Have a look at the lesson in pure maths on simultaneous equations under the algebra and functions topic if you're not sure about this. So I can write the acceleration is 8g minus 15 over 13. Remember that g is just 9.8 on the surface of the Earth, which I assume we are here. Divide by 13, stick that in a calculator, and we get an acceleration of 4.88 meters per second squared. And there's your acceleration. So all I've done there is rearranged. I've solved the simultaneous equations, done a bit of rearranging, and subbed in for g. Remember that g is just 9.8 meters per second squared on the surface of the Earth, okay, which is the only value, generally speaking, we're going to use for pulley systems because they're normally on the surface of the Earth. Part C, we want to find the tension in the cable. Well, all I can do is go back to one of my equations. I'm going to take the equation for particle x, because I now know what A is. A was 4.88. So I can just substitute it in. So I get t minus 15 is 5 times the acceleration, and rearrange for the tension. And that's going to give me a tension of 39.4 newtons. Okay, so I found the acceleration and I found the tension. Lots of pulley questions have this format at the start. Find the equations of motion, find the acceleration, find the tension. It's after this they tend to start differing a bit, but parts A, B, and C are pretty common for most pulley questions. Moving on to part D, it says find the time taken between the system being released and Y hitting the ground. This is really nothing to do with forces, it's actually a Solve4x question. Think about what we know for particle Y. Let's have a look at it. The displacement we know is 2.5 meters. That was in the question previously. Okay, so this distance is 2.5 meters. Now we need to think about which way we're taking as positive here. I'm going to take downwards as positive. Okay, that means the displacement is positive 2.5 meters because the particle's moving down. Now the initial velocity was 0, because I don't know if you remember from the question, but it said that it was released from rest, which means it's got a velocity of 0. We don't know what v is, and to be honest, we don't really care. The acceleration is the acceleration we've just found. It's 4.88 meters per second. It's accelerating towards the ground, it's accelerating downwards. So A is also positive in this case. And T is the thing we want to know. So we can have a look at these and choose which Solve4x equation we need. You can see we've got S, U, A, and T. So the equation we want is S is ut plus half of AT squared. Notice that U is 0, so this whole term can disappear. We're just left with S is half of AT squared. Do a bit of rearranging to get T by itself. And then we just substitute in. S was 2.5. A is 4.88. Remember that A is not 9.8 in this situation. It's still connected to the cable. So we've just found the acceleration of the system in part B, and that's the acceleration we need to use. If we put that in a calculator, we get 1.01 seconds. Okay, that's how long it takes before particle Y hits the ground. The last bit of this question is part E, which says, what would the acceleration of Y have been if the string was cut? Remember, if the string was cut, there's no tension. If there's no tension, the only force acting on it is the weight. If it's in free fall, the acceleration is due to gravity, so it's G. And we know G is 9.8 meters per second squared. Okay, that's all there is to that last part. It's just saying if the string was cut, what would the new acceleration be? And it would just be 9.8 meters per second squared. If we actually have a look at the equation for particle Y up here, if you take t as 0, right, can you see that we just get the equation 8g is 8a? If the string was cut, the tension would be 0, so that's all we get. And from that, we can see that the acceleration is just g, because those 8's cancel out. Okay, which shows that it's going to fall at 9.8 meters per second squared. And that's it, and that's all I've got for mechanics. It's the end of all the mechanics topics there, so hopefully you found the videos really helpful for this topic. And if you looked at the statistics one as well, I hope you found those useful for your revision. As always, have a look at the Solve4x website if you're interested in doing more questions on the topic we've just looked at on looking at pulleys. All the problem papers are there, the quiz questions are there, there's exam questions there as well, both ones from exam boards and ones that we've made up to give you more practice, and there's a summary of everything we've been through there as well, so please make use of the resources there. Thank you very much for watching this, and I will see you next time.